In this video, we're going to talk about continuation of the last video and talk a little bit about formatting floating point numbers. Set precision says double value with a value of 2, for example, says double values should print with 2 digits of precision to the right of the decimal point. This is called a parameterized string manipulator, and these are all defined in IOmanip. And these are used with various strings to improve their usability, readability, etc. Endo is a non-parameterized string manipulator. If the precision is not specified, floating point values are output with 6 digits. String manipulator fixed outputs in a fixed point format, showing floating point numbers as a specific number of digits. Fixed point formatting prints decimal numbers and trailing zeros, even for whole numbers. Otherwise, values print without trailing zeros and decimal point. When string manipulators fixed and set precision are used, the value is rounded to the number of decimal positions past the set precision. The value, however, is unaltered. You can force a decimal point to appear using string manipulator show point, and if it's specified without fixed, trailing zeros won't print. And those are both in IOstring. We can also prevent narrowing conversions with list initializers. Consider this statement: unsigned int student 1. It can also be written with an equal sign or directly. For fundamental variable types, list initialization syntax prevents narrowing conversions. For example, x equals 12.7 could be assigned to int. A double is converted to int by truncating. The actual value would be assigned as 12. Many compilers may generate warnings, but it'll allow it to compile. However, if we use list initializer syntax, it will not compile. So, compound assignment operators abbreviate assignment to simplify things. For example, the plus equal operator adds the expression on the right to the variable on the left. So, variable equals variable operator expression can be rewritten. Usually it's variable operator equals expression. So assignment C plus 3 is the same as writing C equals C plus 3. You can do that with times, you can do that with multiplication. Then there's the increment and decrement operators. C++ has 2 unary operators for adding 1. Increment plus plus and decrement minus minus. Now, where you put these operators is important. Plus plus A will increment A before its use. A plus plus will increment it after. Similarly with decrement. So here's an example. So let's pop it over here. So here's some simple examples. Let's define C equals 0. And then let's say C plus plus. First, let's say initial value of C. We see 0. So now, what we'll do is this. We'll say value of C plus plus. So we'll increment it before we use it. So now we should expect it to say 1. Now, if we do this, we would expect it to say 1 again. But if we print the final, it'll be 2. Now, we can also do things like we talked about earlier 2, which is the same thing as C equals plus 2. We run it. Notice here we end at 2, we add 2, and then we get 6. So that's the results we'd expected. So one other thing to remember is that fundamental types are not portable. C++ requires all variables to have a type. In C and C++, programmers often write separate versions of programs for different platforms because fundamental types are not guaranteed. On one machine, and it might be 16 bits. On a second machine, it could be 64. There are some definitions that are common, such as the short and long, but even those can be a little flaky.